All right, you guys, we're going to look at Lesson 5, Algebra Properties. Go ahead and scan the lesson and predict 2 things you will learn about properties. Some sample answers that you could have used were why the order 2 numbers are added or multiplied does not change the answer. That applies to one property that we'll talk about today. Another sample answer is why the way in which numbers are grouped when added or multiplied does not change the answer. Now those two kind of look similar, but there's this word here, grouped, that changes the type of property we're referring to. We'll look at both of those in our lesson today. First, let's look at your real-world link. Angelica and Nari are baking cookies for a bake sale fundraiser. Angelica baked 6 sheets with 10 cookies each, and Nari baked 10 sheets with 6 cookies each. Pause the video and answer these 4 real-world link exercises. So let's see how you did. For exercise 1, we were to determine the total number of cookies that Angelica baked. Well, we know that she baked 6 sheets with 10 cookies on each sheet. So if we multiply 6 times 10, we get 60 total cookies. In example 2, we were to find the total number of cookies for Nari. Well, we know that she used 10 sheets and baked 6 cookies on each of those. So if we multiply 10 times 6, we get 60 total cookies. For exercise 3, what do you notice about your answers for exercise 1 and 2? Well, what we should have noticed is that we get the same answer. Both girls baked 60 cookies. Exercise 4 says, what do these exercises suggest about the order in which factors are multiplied? Well, what we should notice is that we're using the same factors in exercises 1 and 2, but all they are switched around. Notice that we get the same answer even when they're switched around. So, for multiplying factors, the order does not matter. Another way of thinking about it is looking at each of the ladies' cookies in terms of an array. 60 sheets, or 6 sheets, times 10 cookies gives us an array that looks like this, where sheets are rows and cookies are columns. But when we multiply 10 by 6, we get a different looking array. Although the arrays look different, they have the same total, 60 cookies. So does order matter when multiplying? No. We got 60 either way. Now the commutative property is a property that says the order in which 2 numbers are added or multiplied does not change the sum or product. Notice here, we're adding 7 and 9 and 9 and 7, and we're going to get the same answer either way. The same thing is true for when we multiply 4 and 6. 4 times 6 should get us the same thing as when we multiply 6 times 4. The associative property says the way in which 3 numbers are grouped when they are added or multiplied does not change their sum or product. Take a look here, where 9 and 4 are grouped in parentheses, and 3 is not. 3 plus the quantity 9 plus 4 is going to give us the same answer as if we first added 3 and 9 in parentheses and then 4. The same is true for multiplication. Now let's look at the identity properties. The identity properties say that the sum of an add-in and 0 is the add-in, and that the product of a factor and 1 is the factor. Well, we know that if you add 0 to any number, it's going to equal itself. And if you multiply any number times 1, it should be that number. Those are the identity properties. Now, properties are statements that are true for any number. So if they're true for any number, we can use variables to represent the commutative properties, the associative properties, as well as the identity properties, where A and B are used in the commutative property and switched. A, B, and C are grouped differently in the associative properties, and A is used to represent any number plus 0 and any number plus 1. The expressions 6 times 10 and 10 times 6 are called equivalent expressions because they have the same value, and they illustrate the commutative property. Well, let's take a look at a few examples of how these properties work. Determine whether the two expressions are equivalent. If so, tell what property is applied. If not, explain why. Well, let's make sure we think through how these examples are working. How were the numbers and operations from both expressions alike, and how were they different in example number 1? Well, if we look, we've got the same numbers here, 15, 5, and 8, but they're grouped differently. Right here, we've got 5 and 8 in parentheses, and in this expression, 15 and 5. So what property states that, when we group three numbers differently, we still get the same sum? That's the associative property. So if we're modeling the associative property, that should tell us that the two equations are equivalent to each other. Look at example number 2. In example number 2, let's answer those same types of questions. How are the numbers and operations for both expressions alike? Well, I can see here that they have the same three numbers, 20, 12, and 3, and they have subtraction, but they're different in that the grouping is different. In parentheses for the first expression is 20 minus 12, and the second, 12 minus 3. So let's answer the second question. When subtracting numbers, does grouping them differently change the final answer? Well, if we simplified 20 minus 12 minus 3, first we do 20 minus 12, and that would give us 8, and 8 minus 3 is 5. And if we followed order of operations in the second expression, we would do 12 minus 3, and that would give us 9, and 20 minus 9 is 11. 5 and 11 are not equal to each other, so these are not equivalent expressions, even though they look like they're showing us the associative property. Excuse me. In example number 3, let's think about what operations are being used and how those relate to the numbers. Well, we've got 34 plus 0, and 34 is our two expressions. What is the sum of 34 plus 0? Well, any number plus 0 should equal itself, so the answer there is going to be 34. What property does this demonstrate? Well, if we're talking about adding 0, we're talking about the identity property. And are the expressions equivalent? Yes, because 34 plus 0 is equal to 34. Look at example number 4. How are the expressions alike and how are they different? Well, they both got 20 and 5, and they both have a division symbol, so they're alike in some ways. They have the same numbers and operations, but they're different in that the numbers are switched. 20 is first here, and 5 is second. 20 is our dividend, and 5 is our divisor. And in this expression, 5 is the dividend, and 20 is the divisor. So let's determine if those expressions are equivalent. Well, the commutative property does not hold for division. To prove this, we simplify the expressions in example 4. 20 divided by 5 is equal to 4, but 5 divided by 20 gives us 1/4. And because those two numbers are different, they are not equivalent to each other. Does order matter when you divide? Yes, it does. Because when we divide, we get different answers when we switch the numbers. Order does matter with division, and it also matters with subtraction. Pause the video and determine whether the two expressions are equivalent. If so, tell what property is applied. If not, explain why for both A and B. Let's see how you did. So in A, we are looking at 5 times the quantity 6 times 3 and the quantity 5 times 6 times 3 and determining if they're equivalent. Well, if we simplify 6 times 3 first, because it's in parentheses, we get 18. Times 5 gives us 90. And if we first multiply 5 times 6, we get 30 times 3 gives us 90. So because we got the same answer, these two expressions are equivalent to each other. Let's check out B and see if they are equivalent. Well, 27 divided by 3 gives us 9, And when we divide 3 by 27, we get 1/9. Those two numbers are not equal to each other, so these two expressions are not equivalent. When we have equivalent expressions, we are modeling one of the properties we talked about before. So what property are we using here? We've got the same three numbers, but the grouping is different. So that is the associative property. And for B, because the two expressions were not equivalent to each other, we were not modeling a property. No, the first quotient is 9 and the second quotient is 1/9. Properties can be also used to write equivalent expressions and to solve problems. Let's think about how we can use properties to help us solve an example number 5. It says, in a recent season, the Kansas Jayhawks have 15 guards, 4 forwards, and 3 centers on their roster. Write two equivalent expressions using the associative property that can be used to find the total number of players on the roster. Now, they're telling us what property to use, the associative property. That's the one that has to do with grouping. So when we use the associative property, we should be using parentheses. Well, let's think through it. How can you determine the total number of players on the roster? Well, we can add the 15 guards, the 4 forwards, and the 3 centers together. Can you group the numbers differently and get the same answer or the same sum? Well, let's try it. If we add 15 plus the quantity 4 plus 3, we get 15 plus 7, and that gives us 22. And if we group them differently and add 15 and 4 and then 3, we also get 22. So yes, we can group them differently and get the same sum. That lets us know that we are properly modeling the associative property. Try this one on your own and we'll see how you do. Okay, so this problem says, Brandy earned $7 babysitting and $12 cleaning out the garage. Write two equivalent expressions using the commutative property that can be used to find the total amount she earned. Well, the commutative property says that we can add or multiply two numbers together and order doesn't matter. So we first add $7, then $12 to it, we get $19. And we can switch the order and get the same amount. Here we're modeling the commutative property by switching the order of the add-ins and still getting the same sum. Now let's take a look at our real-world example. It says, the area of a triangle can be found using the expression 1/2 times b times h, where b is the base and h is the height. Over here we have our triangle that we're referring to in the problem, where 15 is our base, 12 feet is our height, and if we connect those points, we see the triangle. The problem is asking us to find the area of the triangle. What expression are you given to find the area of the triangle? Well, it's up top. It's at 1/2 times b times h, where b is the base and h is the height. How will you find the area? Well, we're going to take that expression and we're going to replace the b and the h with their known values. So, with what will you replace b? B is the base, so on our triangle, that's 15 feet. So we're going to replace b with 15. With what will you replace h? We're going to replace h with 12 feet because 12 feet is the height of our triangle. So our new expression is 1/2 times 15 times 12. Now notice here that the commutative property was used and 12 and 15 were switched in the expression. Can you think why? Well, it's easier to multiply 1/2 times 12 than it is 1/2 times 15. Half of 12 is 6, and that was much easier for us to find than half of 15. So we switch them around so that we can solve the problem in an easier fashion. 6 times 15 gives us 90, so the area of the triangle is 90 square feet. Try this last problem on your own, and we'll see how you do. Okay, so we're going to ask questions the same way we did before. Vicky earned $6 an hour while working 8 hours over the weekend. She put 1/3 of what she earned in a savings account. So, what do we need to find? We need to find how much she put into the account. The expression that we're going to use is going to be 1/3 times the hours she worked times the dollars per hour that she receives. So we're going to find that by replacing the hours she worked and replacing the number of hours or the number of dollars per hour she receives into the expression. So our new expression is 1/3 times 11 times 6. Now, with what will we replace the hours worked? Well, we know in the problem that she worked 11 hours over the weekend. And we're going to replace the dollars per hour with 6 because in the problem it tells us she works $6 per hour. Now, we're going to use the commutative property and switch the 6 and the 11 around because it's easier to find 1/3 of 6. 1/3 of 6 is 2, and we can easily multiply 2 times 11 and get 22. Again, notice we use the commutative property by switching the 6 and the 11 so that we can multiply easier. So the answer, how much did she put into her account? Was $22. Now, what I would like for you to do is follow these next moves. First, try the guided practice problems on your own. That's all 6 of them. After you've completed the guided practice, you can go over to the QR code at the solution station and check your answers. Once you've done that, you can go back into our Edmodo page and answer the exit ticket question for Algebra-Properties. Again, you're going to try the guided practice problems on your own, check your answers by scanning the QR code at the solution station, and then submitting your answer to the Algebra-Properties exit ticket in Edmodo.